Hello, Model 3. Today, we're going to talk about Lesson 2 in Unit 1, Graphic Representation of Moving in a Straight Line. Look, before we study this lesson, first of all, we need to know why our physicists use other mathematical relations like graphs and tables. Look, give reason. So this is why, in order to number one, predict the relation between certain physical quantities, understand the practical results, and to describe the physical phenomena in easier way. Now, first of all, let's talk about graphs of speed. In the last lesson, you studied the speed. Speed equals speed equals d over t, distance over time. And we have two types of speed, regular and irregular. So, for the regular speed, we can represent regular speed by using either or these two graphs. Look, the first graph between distance and time. So it will be like this, a straight line passing through the origin point. Why? Give reason. Of course, because there is a direct relationship between distance and time, so the graph must be like this. But the second graph is between speed and time, and it will be like this, a parallel line to time axis, to x-axis. Look, it must be like this. Give reason. Because as the time passes, speed is regular, uniform, constant, and it doesn't change. So it must be a parallel line to x-axis. But pay attention. Here, if the graph between distance and time, and we have a parallel line here to time axis or x-axis, here this means that as the time passes, distance doesn't change. So we have here body at rest. Now let's solve a problem from this graph. First of all, let's study this graph. We have a graph between distance with kilometers and time with hours. From A to B, regular speed. From B to C, body at rest. From C to T to D, also regular speed. Now, first of all, calculate the average speed during the trip. Average speed, so total distance over total time. Total distance here from the graph, 50 kilometer in 5 hours. So 50 over 5, 10 kilometer per hour. Then, what is the period in which the bike stops? BC. And what is the time of this stopping? Look at the time axis BC from 2 hours to 4 hours, which means 4 minus 2. The time here of stopping is 2 hours. Number 3. What are the periods during which the bike moves at a regular speed? AB and CD. But what is the period during which the regular speed of the bike is the greatest? So here we need to calculate the speed through AB and CD. Through AB, distance 20 times 2. So 20 divided 2, 10 kilometers per hour. While in case of CD, the distance here from 20 to 50, which means 30 kilometers, and the time from 4 to 5, which means 1 hour. So 30 over 1 equals 30 kilometers per hour, and obviously the regular speed through CD is the greatest. But now, you studied before that we have regular and irregular speed. We said from a while the graphs of regular speed. What about the graphs of irregular speed? Graphs between distance and time, but we'll get anything except the straight line. Curve, zigzag, whatever. that was for the speed.